Okay, so moving on from section 7.1, we're finished with doing problems that only involve integration by parts. So we're going to need that, as we go through this course. We're going to see a bunch of integration by parts problems. It's just, the nature of things. So we're going to move on to trigonometric integrals. This section and the next section deals with trigonometric functions. This section is really just about how to manipulate these to make U substitution possible. So for this one, we're going to have to remember a bunch of our trig identities that we all hate memorizing, but I'll pull them up as we need them, write them down. So this section starts off with an example. Get the pen going. So we have an example. So evaluate the integral of cosine cubed x dx. And when you're looking at this, what you should say is, okay, integration by parts doesn't seem like a good idea. I'm going to have to integrate dx, and that's going to bring an x into the mix, and I don't want to have to deal with, more complicated functions. So what we're going to do with all these trigonometric integrals is we're going to use identities to simplify them and then perform a U substitution. So the idea is, if I had a sine of x somewhere in here, then I could do a U substitution because the derivative of cosine is negative sine. So let's try and write this so that sine appears somewhere. So if I separate this cosine cubed into cosine squared times cosine, still don't have a sine here, but what you should notice is I have a cosine squared here. What we're going to do with that cosine squared is we're going to rewrite it. We're going to use the identity sine squared plus cosine squared equal to 1 because we're on the unit circle. And that tells me that cosine squared then is 1 minus sine squared x. And now I can do a U substitution. So if I let U equal to sine of x, du will then be cosine of x dx. When I plug this in now, and then of course solving for dx, I get 1 over cosine of x. Sorry, I accidentally hit. Finger actually accidentally touched new page. So I have dx is 1 over cosine of x dx. We're going to plug this in. We're going to get, this is the integral, box this off. 1 minus, sine is now u, so I get u squared. Cosine of x don't have anything yet. But dx is 1 over cosine of x du. Now I see that my cosines cancel, and I can do this integral. This is the integral of 1 minus u squared du. And so if I do this, I'm going to get u minus u cubed over 3 plus a constant for my integration constant. And when I plug this all back in, because I need it in terms of x, I'm going to get sine of x minus sine cubed of x. Let me write that a little larger so it's not ambiguous. Sine cubed of x over 3 plus a constant. And that's going to be my final answer here. So again, to reiterate, we haven't done anything new here. We're not really learning. So what we're going to learn here is not really a technique, but a set of rules for how to evaluate these things. Because there is no trick like a U substitution this isn't like integration by parts or U substitution. This is more just learning how to work with these things in order to write them in ways that allow us to integrate them. And it's always going to be a U substitution. Should always be a U substitution. I might be wrong, but I think all the examples in here end up being U substitutions. To move on to the next page, and there's that part I'd begun drawing, and then the page changed. So we're going to move on to example 2. So we're going to do a bunch of examples, and we'll write down some rules for how to follow these. That's useful for if you need to look up what to do in what case. So let's do the integral. We're going to evaluate the integral sine to the fifth cosine squared dx. And now you just have to start thinking, okay, what are the different things I could do and what's going to happen? So just like before, I could try and write, cosine squared as 1 minus sine squared. I don't think that's going to be the best option here because, when you do that, you're not going to be left with anything that will be useful here. So what we want to do is, because we have this cosine floating around, I want to somehow separate, a factor of sine. I'm going to do that. So I'm going to write this as the integral sine of x, sine to the fourth of x, cosine squared x, dx. The reason I've done that is, I want one factor of cosine because I'm already thinking about, I want to let u equal cosine of x. So I'll need that sine of x dx. But now I need to write everything else in terms of cosine. So I'm going to leave the sine alone. And now I need to write sine to the fourth of x as something in terms of cosine. So let's first write it like this. So sine to the fourth just is another way of saying sine squared squared. And now I can convert this to something in terms of cosine. So remember, sine squared is 1 minus cosine squared. I'm going to square that. I have a cosine squared floating around. And now, I have these cosines here. And I have a sine here, sine dx. So it looks like I can do a u substitution now. It looks like I can set u equal to cosine x. That way du is negative sine of x dx. dx is minus 1 over sine of x du. If I plug this in, I'm going to have the integral sine of x, 1 minus cosine squared, or cosine of x is u. So I get 1 minus u squared. Square that. Have another cosine squared, which is a u squared. dx is minus 1 over sine of x, all multiplied by a factor of du. Let's separate this. Now when I simplify, I can see that I have sine of x minus, or 1 over sine of x, so those cancel. I'm going to pull the minus sign out in front of the integral, so I get minus the integral 1 minus u squared squared, u squared du. This is a polynomial. We know how to do these pretty quickly. This is negative the integral 1 minus u squared is 1 minus 2u squared plus u to the fourth, u squared. And now we're just going to keep going. So this is negative integral. So we had a u squared minus 2 u to the fourth plus a u to the sixth, I believe. Let me double check. Yes. And now we're going to integrate this. So negative u cubed over 3 minus 2/5 u to the fifth plus 1/6 u to the sixth plus an integration constant. Then we're going to go back and plug in for u. So this is minus cosine cubed of x divided by 3 minus 2/5 cosine to the fifth of x plus 1/6 cosine to the sixth of x plus c. And just distribute that minus sign, and we're going to get 2/5 cosine to the fifth of x. Write it in, leading factor is positive. Minus 1/3 cosine cubed of x minus 1/6 cosine to the sixth of x plus your arbitrary constant. And that takes care of that. So again, you'll notice that, I didn't do anything tricky or crazy. It was a u substitution in the end. Just about, looking at this thing and trying to figure out, okay, how can I write this in order to get, in order to make a U substitution obvious and easy. So I'm going to stop the video here. We're going to continue on, do a couple more examples. We're also going to write down, there are a couple, again, I don't know how easy they are to memorize. I've never memorized them. I've just always, just kind of played around with these functions until, you can get something to integrate. But we'll write them down in case that's helpful to some people. I'm going to stop the video here.